Okay. Today we are talking about reflection. So I'm made aware that if I walk too far away from my computer with my microphone, it cuts out the range, and then it kills the sound of the whole rest of the video. All right. Okay. Everybody see this laser? Yeah. Yes. Good. Now. Oh. Shot through the heart. All right. Now, everybody see this mirror? Where do you think the laser is going to end up when it hits this mirror? Ready? Set. Boop. Find it. Everybody see it up on the. Okay. Now, if I come over, well, I don't have much of a range here. If I come over here, hypothesize where it's going to end up. Ready? Okay. This is demonstrating the law of reflection. Okay. It is not that involved. What the law of reflection says is the angle in is equal to the angle out. Okay? The angle in is equal to the angle out. Now, there are some subtleties that are important. When we are talking about light rays, rays of light, and measuring the angle, we're always measuring them from the normal line. Okay, do you remember when we were doing free body diagrams, we had the normal force. Normal force is always perpendicular to the surface. The normal line is always perpendicular to the surface. Okay? So when we're measuring an angle with rays of light, we measure this angle, not this angle. Everybody see that? This is the angle, not this angle. Okay? We measure this angle, not that angle. Always from the normal line. Okay? So the angle in is called the angle of incidence, or incident angle. And the angle out is called the angle of reflection. So angle of incidence is equal to the angle of reflection. Okay, not too crazy there. Good with that. So when this laser is, you guys see that? You can see that. Okay. You can see that. I can too. I can see it over here. Can also see it over here. We know where the laser is originating from. How is it that I'm able to see the laser, and you are too, regardless of where you're sitting? Like everybody in this room can see that laser beam right there. Why? Does that? I mean, it doesn't seem to really demonstrate the law of reflection because I can see it over here. I can also see it over here. How is that possible? JP. Okay. It does, but why does it not just bounce off in one direction? I agree with everything you said. Good guess. The whiteboard isn't smooth. It is rough. It is imperfect surface. And so the law of reflection still holds true. It's just hitting at crazy angles. And so we're able to see it in all different ways because when it hits, it bounces off crazy like. Still obeying the law of reflection. This is known as a diffused reflection. Ben. Great question. Glass would be smoother. Yes. JP.
So like with the mirror and everything, you can still see it on the mirror.
Okay.
Like, is it because it's still rough? It's not completely smooth.
Yeah, hang on to that. That's a great follow-up question. Okay. So when I go from the whiteboard to the mirror, tell your neighbor why the light gets dimmer going from the whiteboard to the mirror. Okay. Tell your neighbor what would happen if this is a perfect mirror. Perfectly smooth. Ben. You'd see it. So like the fact that you can see this tells me there's imperfections. There is a scratch. Like I actually have it on a scratch. I'll put it on a bigger scratch. I don't know if you can see that any better. But yeah, that scratch would do something like this. Does that make sense? So it would cause light to be diffused. With that, Chippy.
So why does light get magnified through glass?
We will talk about that Friday. Actually, next Monday. We'll get there. Okay. All right. So when we're with reflections, talking about plane mirrors. So these are just normal mirrors that we see. We look in looking glass mirrors type stuff. So when we see an object, it's helpful to think of eyes like the catcher of light, not the emitter. Like you are not Superman, like laser eyes or Cyclops. Okay, you, you your eyes are catching light. Light's going into your eyes. Okay, so light comes off the object, bounces off the mirror into your eyes, obeying the law of reflection. And you think you see the object here. Okay. I don't know if you ever observed like a baby or a dog or a cat or a bird interact with itself in a mirror. It's quite entertaining. Um, so um, this is known as the, the object, and this is known as the image. The distance away from this is your object distance. And this is your image distance. On a plane mirror, your image distance is equal to your object's distance. So as you look at stuff, the image looks just as far, your reflection, your image in the mirror looks just as far as you are from the plane of the mirror. Like if a baby looks in a mirror, it thinks, oh, I'm looking at another baby. And like go up to it and like, oh, I touch. And they think they're touching another baby. Okay, or dogs like go nuts, thinking they're attacking something. Oh, that's not battery I have. Whatever. Okay. Good with that? All right, so we went through that, image distance, object distance. Okay. Yeah. That's cool. All right. Now. Oh, this is fun.
There it is.
Whoa, 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 whoa. We're going into the forever. Whoa. That was cool. All right. So, Kendall, can you see yourself? Rachel, can you see yourself? But can you see Kendall?
I can like, I'm gonna see her tilted. Yeah, no.
Okay, we're good? Okay. So, Kendall, can you see Rachel? Rachel, can you see Kendall now? Okay. So, if you can see somebody in the mirror, they can see you. That's so creepy. Okay. Is everybody good with that? Can you like figure out the array, like which way the light rays are going to make you see each other? Okay. So on some trucks, semi trucks, they have this little bumper sticker that says like, make sure I can see your face, or you can see my face. Because if you can see their face in the mirror, the side mirror, they can see you. You can't see their face, they can't see you. Okay, you want to stay out of their blind spot. Good with that? Okay. All right.
Can you read? Yeah, but like that's a scary part. Why is that a scary word? Like a weird
Ambulance.
Ambulance.
You guys are good. So back in the day when we had lockers, these used to be popular.
Oh my God. I think the no one there's
Okay. Pretend like this. Pretend like this is your rear view mirror, and I'm the ambulance driver, and I'm coming behind you. So turn around. We're gonna use this mirror. Turn around, and then we're going to use this as a rear view mirror. Crazy. Ambulance. Get out of the way. Very good. Like if you turn around in your seat, you look back that way, and then pretend this is your rear view mirror, and then look at the board. Okay? Good at that? So your right and left are inverted.
I need someone to take a picture for me.
All right, next question.
Like if you can see someone, they can see you. Okay, I'm not as stressed as you. Sorry. That's why like. But I still am my nose. So what if you can't see them and they still see you? Yes. Well then, no. Then I was safe in that sense. I could see like two people. Yeah. Two people can see you.
Okay. Then we have a hypothesis. All right. I need 2 volunteers. Dos. 1, 2.
What the heck?
Yeah, I'm just mixing it up. Come on up, Bennett.
No, I want you.
Crushed him. All right. All right. So, need a mirror holder and a viewer. Okay. You probably need 2 hands. So lift this up until you can see the top of your head. Yeah. Right there. All right. And I'm going to take away the bottom side, and you tell me when your toes just about to disappear. And try,
toes already gone.
And try to there, right there. You got it. Can you still see it? Toes.
My toes, yeah.
Tell me when about.
You're right there.
Okay. Now come forward. Can you still see your toes?
No, not really.
Oh. All right, now.
I can see him now.
Okay. Back up real far. Can you see them?
Yeah.
Okay, so come on real close, like to here. Okay, what this is about half his height. Get that? Correct answer is D. Thank you. Thank you, my volunteers. Yep. He could see regardless of where he was. Watch this. Bennett, here you go. Oh, sorry, I didn't frisbee it good enough. All right, now. You ready? Hold this arm, or like hold this close. Wink. Look how much of your head is in the mirror. Like eyebrow to ear, temple to temple, ear to ear. Okay? Now, hold it at arm's length and see how much more or less. It's the same. Wink one eye. This is.
It doesn't say one eye to mirror, one eye. When you see
This is.
and you wink one eye.
Okay. When you.
Prove it. I do it every morning when I look around. Like I got what is the minimum thing that a mirror can be?
Come here. Come here. You want to fight? We can fight.
I don't think I know what your question is.
Okay. Can you see the top of your head?
Yes.
How about now?
No.
Right there?
No. Okay, yes.
Okay. Now, can you see your toes?
No.
Can't?
No. No.
Sorry.
Yeah, I can do that. I can do it.
Now? Now?
A little bit.
Okay, so in that region.
Yeah.
Okay. Come close. Can you still see them?
Yeah.
Come closer. You still see them?
Yeah.
Back up.
But I don't. That's like not what is in my head when you ask that question.
Oh, what's on your question?
Like when you're sitting in mirror on the wall. Okay. Like in my head, like no, when you sit like on the wall and you are sitting there,
Still works.
yeah, well, I've done a dishwasher. Really? Okay, but in the morning when I wake up, I have my mirror on my wall. Okay, and I have to back up and like walk to the other side of the mirror to be able to see myself in the mirror. Here, this is. Can I show you what I think? Like on my phone.
Okay, it needs to be vertical.
I have my camera, which is like a mirror.
Yeah.
I stand up. I see this. I back up. I see the door.
Okay, that's not a mirror.
But it is.
No, it isn't.
Why is it not? You can't tell me it's not. That changes my perspective.
Try it. Try it.
What?
Cover up your mirror and see how much. Try it. Do a little experiment. Okay. Here's why.
This is like I fully get it. I don't get it. I don't get it. I don't understand. Just don't believe it. This is the right answer.
Here we go. Here's why. As you look in a mirror, light comes off your toe, bounces, obeys a lot of reflection, and goes into your eye. You don't need all that. Light comes off the top of your head, obeys a lot of reflection, so you just don't need that little port. You just need that part here, regardless of how far you are away, because light still is going to go here, bounces, obeys a law of reflection into your eye. regardless of how close or far away you are. If you're ever looking at yourself, this is true. If you're looking at other things, then this does not hold true. Like right now, as I'm far away, all I got is Isaiah and CJ. But if I do this, I can see this whole right side.
So what you're telling me is, as I get closer, I can see more.
Yeah.
But when I get further away, I can see.
The field of view in here is more net. Sure. No. Look. Right here, bouncing off. This light coming in is going in a lot of different directions. Here, I can only get the light coming off. Here we go. Let's see how we do this.
I no longer like the mirror.
Yeah.
When's the test? Next week? Yeah.
Mr. Smiley, remember magnets?
Yep. All right. Another popular question that comes up is like, how do two-way mirrors work? All right. So these are made to be semi-reflective, semi-transparent. So the one-way glass, yeah. So the side that looks like a mirror is the side that's brighter. The side that looks like a window is darker. Okay. So here, these people see this as a window. The people in the conference room will see this as a mirror. Okay. With aviator glasses, same idea. It's bright on the outside, but it's dark close to your head, close to your eyeball. Okay. So you're able to see through, but everybody else sees a reflection.
In the interrogation country, they use those. So if I turn all the lights off on the side that we were interrogating, turn all the lights off on the other side, then I'd be able to see.
Be flipped. Yep. Exactly. So with both lights on, this is what you would see. Okay. So like here, this guy sees the reflection, but they can see through. This person being interrogated can see these people as well, just like these guys are seeing them because there's a light on in here. Okay, Maddox.
So if both rooms had the same brightness of light,
It'd be partially mirror, partially window.
Okay.
Like you can see this guy's reflection. Okay, CJ. Okay.
So he has the piece of paper with the charging block, right?
Okay.
And he puts it up against the mirror, and the mirror knows it's there. How does that work?
How does it know it's there?
I don't know.
I don't understand how.
Like how can you see it when you look into the mirror?
The charger block, I can see it. Look, because we're on.
Oh, someone showed. That's just an angle thing.
Let me see.
That's just he's close enough to see it. Like you're just. I mean, you can do it right now. Doesn't matter what you have. Just grab two. Probably not a second mirror. But like, grab your wallet. Light's just coming off of. It's just a glancing blow, and be able to bounce off into your eyes. Okay, good there. Okay, switching gears. Boop, 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 boop. All right, we're gonna look at polarization. What?
I was terrible at this.
You'll be all right. All right, so here. What I have is a polarization filter. Okay. Now, what I have here is another polarization filter. Wow, that's crazy. What I'm going to do is I'm going to overlap these polarization filters. Ready? 3, 2, 1. Wow, it's a little darker. But check this out. If I rotate one of them, crazy. Okay. So take one pass or take one, then buddy up. Just one, buddy up. Maybe I have enough for two. Actually, go ahead and take two. I think I've got enough for two of them.
How many do I take?
Take two. I think I've got enough. Six.
That's so crazy. How is that? Did you even sleep well? I can barely even sleep. That's the second time. Barely. So like right about here. Actually, no. I guess you kind of.
I have to.
Yeah, morning.
Oh, I have to.
Is this related to like?
I don't know how.
Okay, wait. Is this related to like the glasses when then you go outside and then
Oh no, I think those are different.
Whoa, we gotta do what's this?
Same thing. Oh, sorry.
That's how you look at.
Is it like we?
Ah, scratching.
First day.
There. Good. What we got two?
I don't have to. Oh my gosh.
What happened to your
He
second?
stole mine. That's why.
All right. Now, here's how this works.
Oh wait.
Oh my gosh. My allergy.
All right. See, hang on tight.
Okay.
Okay. All right. So, light is a wave, correct? Okay. So this is going to be unpolarized light. Where the light's going like this. It's going like sideways. It's going angled. It's going diagonal like that. And so unpolarized light looks like it's kind of all over the place. Okay. Now, this is going to represent our polarization filter. And Josh is going to hang on to that real tight. We're going to pass the light through the polarization filter. Okay. So when we pass unpolarized light through it, what gets through is polarized. So light going like this gets through, but light going like this doesn't get through. So the only part that gets through is oriented in a certain direction. So how could you take two polarization filters and cancel it out? Thank you much. Thank you much. Okay. Everybody good with that? If you take two polarization filters and you put them perpendicular to each other, the orientation, cancel it out. Like this. Like this.
You should buy it. Literally 500.
Like reflected? Flipped around.
Donate to the kids.
And then I like take the sunglasses off and flip them around.
Not all the time.
I want to still be able to see this way.
Like aviators? Like the reflector?
Yeah, so I'm wearing aviators.
Yeah.
Just like this,
Yes.
I'm looking at the sea.
Yeah.
And then I take them off and like wear them back.
Yes. Or.
I would still be able to see through it, but the rest of
She's a TikTok average.
I don't think it's as silverish, but it's still reflecting, and you can still see through it. Okay, good with that? Now, why do we care? Okay, so light reflecting off of non-metallic surfaces at a glancing blow, at a glancing angle, at a really like big angle, reflects polarized. So if you're skipping rocks, you throw the rock in like, come on, skip. Stupid rock. Like, why don't you skip? You have to like throw it so it just barely. There we go with that.
Yes, sir.
Right here, we have multiple conversations that aren't focused. Multiple conversations. Okay, the light that's coming in and bounces off of a non-metallic surface reflects polarized. If you look at a glare on the floor, on your desk, through this, and then rotate it, you should be able to remove the glare. Someone first hour is like, hey, if I look at your head, I can take the glare off your head, Mr. Smiley. I'm like, oh, all right. Look at that. There it is. Took it off. Oh, that's so cool. Look at that, Mr. Smiley. Just took it. Glare right off your head. Boom. I'm a demonstration, just didn't even know it. Okay, good with that. So, when you go fishing, having polarized, some sunglasses are polarized. Okay, meaning they have polarization film. So, when you go fishing, that is a helpful thing. It takes the glare off of water. When you're driving, sometimes it'll take the glare off of other people's windshields. Some glass, like windows on your car, polarized. You can tell when you wear polarized sunglasses, it'll look like a crazy pattern. You're like, oh. Okay. Do that. Some LCD displays are polarized. If you look at your calculator, sometimes it's polarized. Cell phones, some cell phones are polarized. So if you look at the screen with this, didn't do anything there. Okay, but if you looked at underneath your, Okay. Now, real quick with color, pixels, you get your red, green, and blue. Okay. The better picture, the more crisp your picture is, the smaller these pixels are. Okay. Sometimes you get polarization that has like your green is polarized different than your red and your blue, and so you tilt it, you get a magenta. Sometimes your blue is polarized different than your green and blue, so you get a yellow. Okay, so it depends. Like different phones are polarized differently. Ben. That is, I think they have yellow in there as well. I don't know why. I don't, but I think that's the. I think they have a fourth pixel of yellow. I don't know why that does it, but
So flash thing is the same thing. It's like used to like scoreboards and stuff. It's stuff like the video, like for the sport.
no, those I think are just light bulbs. Yeah. Okay, so there's a lot of different liquid crystal displays out there. Okay, do that. Also, you get 3D movies. The glasses they give you are polarized.
I was also scared of 3D movies.
Just VR. Just VR.
I watched a 4D movie and it was Big Water.
Just use that.
No, I don't check. I don't work there anymore. Probably good.
Nice catch. Okay. Now, how this works. How these work. How these work is there's there are two cameras, one showing polarized light going one way, the other is showing polarized light going the other way. Your lenses are polarized differently. So what it does is one side, you get two different perspectives on one for each eyeball, and so it's canceling out, and so you're able to show the adjustment with some depth, okay? So you can look at your neighbor and wink with one eye, and then wink with the other, wearing your goggles. Wink with one eye, look at me, and then wink with the other.
You stay in the same spot.
No, look at my glasses. Look at my glasses.
Oh, yeah, I know what you're talking about now.
Okay? Yeah.
She has a really dumb question. Like, it's gonna
Okay, wait for that to go. Okay, you ready? So, I don't have these type of projectors. So, if you could, I'll swap you out. Glasses for glasses.
That makes sense. What was the first 3D movie you ever saw? Mine was The Lord. I don't know. I don't know how I remember that.
Okay, swap your glasses for glasses.
I think you should listen to Lexi's question.
No, I gave her the answer. Now. So I don't have the question.
No, wait.
Okay. Swap your glasses for
I want
glasses.
to know that answer.
These are the old-fashioned movie theater glasses.
Hey, JP, come on, man.
Swap the glasses for glasses here. Put your 3D glasses in and get your 3D glasses out.
Josh has all of ours.
Yeah.
About English, and I don't like that.
Come. All right, so here. Here we go.
Oh. Oh, I winked right when he switched the picture.
I forgot.
So see if you can figure out how it works. There's a cyan and a red filter.
Let's see it forward.
Cool with that. Okay. Last thing, sun or sky is polarized. And so at 90 degrees to the sun, you get the maximum polarization. We'll talk about that towards the end. All right. If I could, oh, this is going to be interesting. You pass up your mirrors first.